Alrighty, so in this video we're going to take a look at how you can implement global exception handling in your system. My name is Vasily Olenik and you're watching the architecture and detailed design series where we are building a modular monolith notification system from scratch using industry's best practices. Let's address the elephant in the room. No matter how good your system is, it will throw exceptions at some point, in situations you didn't even think were possible. And our clients do not expect to get an exception and a stack trace as a response for a perfectly valid request. This is why you will need an exception handling mechanism in place. By far, the most popular exception handling mechanism in .NET is done by using middlewares or filters. In our case, we're going to take a look at the built-in middleware that you can leverage to set up an exception handling mechanism. I have already done all the plumbing code beforehand, so we're just going to brush through it right now. In our case, we're going to go to utilities and go to error handling. And inside here, we have an installer in place. Basically, we have two methods over here. One is adding the error handling elements to the DI container, if in case in the future you'll want to change it, you'll change it only here. Over here we have services at ProblemDetails. So what is this ProblemDetails? It's basically a standard of letting know the client that something went wrong. In the previous video you might have seen that for fluent validation we specified that an endpoint that validates the payload might return a ProblemDetails response. So what's this ProblemDetails response like? It's basically an RFC standard that looks like this, where you have a couple of default properties like type, title, detail, instance. However, you can add also your custom properties. For example, in this case, a balance of 30 for specific accounts. .NET comes with built-in support for this RFC standard, so we don't need to write any plumbing code whatsoever. The next part is basically this use error handling, where we specify that we want to use the exception handler middleware, use status code pages, and a couple of endpoints. The catch here is basically the error handling endpoints. Over here, I have a single method that is of interest to us right now, which is the exception endpoint, and it will basically throw an invalid operation exception. This is done for POC purposes right now. So back to our installer, what we just need to do is add these two methods to our program.cs. Basically over here, add them to builder services, and down below, add them to the middleware pipeline. Now to demonstrate how it all works, I'm gonna debug the solution. And once it's started, I'm just gonna invoke the exception endpoint over here. So we can see that the new exception is handled. I'm just gonna resume it and return back to the browser. And over here we can see our ProblemDetails response to an unhandled exception set up by only a couple of lines of code. Now I'm gonna stop the solution itself and go back to my error handling installer. What if for example, I want to play around with how the response looks like for the end user? One way to do that is to define an error handling endpoint and specify it inside the middleware. So for that, I'm just gonna insert in here the path to my error handling endpoint, which in my case is just /error. I'm gonna go to error handling endpoints and put a breakpoint over here inside the handle error. Basically, what will happen is when an exception will be thrown, we're gonna hit this endpoint and respectively this method over here. Let me debug the solution once again and we'll see this in action. Now, if I go back to this page and just recall this, we can see that it's still the same exception thrown over here. I'm just gonna resume it. And as expected, we have hit our handle error method, where we can specify, for example, get the exception and just say that we want to return the exception message also. I'm just gonna resume, return back to my browser, and over here we can see that we have the details of the exception that we have thrown away. So yeah, this is a basic setup of how you can handle unexpected exceptions inside your system. However, there is part two. Sometimes you might expect that an exception might be thrown at some point. For example, you have some external communication like reaching out to a service, a legacy system that might be unresponsive for longer periods of time or might be flaky. In such cases, my preferred approach to solve those kind of issues is to introduce the result pattern for those specific contracts And inside the Modular-Monolith, I prefer to have the result pattern for all the public interfaces for any model, since at any point in time, our models can be split apart into different components. In the past, I've built the result code, the plumbing code for the result pattern myself, but at some point I found it redundant, and I just use the Fluent Results library that is very popular right now on GitHub. But as with everything in software, it's not a silver bullet. In case you have some third-party nuggets installed, for example, Hangfire does not understand the result pattern, so you will still need to return to throwing exceptions over there in order to trigger the retry mechanism built into Hangfire. So it's not a silver bullet, and you need to use it with caution and with pragmatism. So yeah, these two are my setups for handling unexpected and expected exceptions inside my system. So yeah, if you like this kind of content, leave a like, subscribe to the channel, click the notification bell down below, and yeah, you might even share this video with your friends to help me grow up the channel. It's greatly appreciated, and see ya next time. Bye!